Hello, everyone. My name is Ian McLaughlin, and I'm a PhD in neuroscience at the University of Pennsylvania. And boy, it was a tough week. My baby got a cold. My wife got a little bit of a cold as well. I had to give a talk, and there was an actual fire in the building that houses my lab. And so, to be clear, when my lab first moved to Penn, our building had fire alarms all the time, which was like torture because, when you're trying to map out some of the neurons that participate in generating anxiety, and you've invested like 2.5 months into the moment that you run your actual experiment and a fire alarm goes off, that's basically 2.5 months down the drain. And so it's hard for me to communicate the depth of my frustration, but it was like the intensity of a supernova or a tsunami or like a sleepy baby who's too tired to actually just go to sleep. And basically all rising scientists encounter these types of speed bumps. So, I think it's safe to say whenever you're hearing from someone who has a PhD in basically any scientific discipline at least, they've also likely encountered these periods of profound frustration. But anyways, because of the little quirks in the fairly old building, the fire alarm used to go off all the time. So I had just assumed that, it was either a fire drill, which they're supposed to run, or just another example of like a steam pipe getting loose or something like that. So I had just given a talk, and almost immediately afterwards, the fire alarm goes off. And, it's been a few years since that period of constant fire alarm. But I just assumed it was, just another false alarm. So everyone exits the building, and I walk by an old friend of mine with whom I've discussed politics in the past. We have very different political leanings. He's also a scientist. He does more sort of basic like stem cell research. But he looks very, very shaken. And he calls my name and he says, the first thing he says is, "It's real this time." And I asked him, what does he mean? And he explains that his entire lab, which is almost an entire floor of the building, is filled with black smoke. And he wasn't sure what happened, but that it was for real this time. And so all this to say, on top of the girls getting sick, it was a hell of a week. So anyways, let's get started. So one of the topics that comes up all the time during live conversations is meditation, and more specifically the effects of meditation on the brain, or at least how meditation can influence the brain, or how the brain can influence meditation. And so there is a study from an institution in Italy, in Lucca, Lucca, I believe is how it's spelled, which is quite close to like Pisa of Leaning Tower fame, and it's also fairly close to Florence, which also seems to be incredibly beautiful, at least a beautiful place to do research. And so this lab did a cognitive neuroscience study using fMRI to evaluate if they might be able to detect an effect of a specific kind of meditation practice on the brain. And so I should note, however, that there's kind of a weird twist to this study that doesn't necessarily have anything to do with the science. It's just kind of an interesting twist. Okay, that said. So to get into this study, it's worth briefly defining fMRI, and not to go too deep into the nitty gritty, but you might have heard of fMRI, or you might have heard of MRI, which is magnetic resonance imaging. When a doctor might have been concerned that you have like a damaged joint, some kind of tissue with the heart or the cardiovascular system is damaged, or maybe you might have had a stroke. But basically what it does is it takes pictures that are static. And, there's basically like snapshots of parts of your body at a specific moment in time. And so here's what a typical MRI might look like, obviously of the brain in this case. But to be clear, you can use MRI to make animations that look absolutely beautiful. But it's a series of these static images. So to give you an idea. So, but, what I want you to notice when you're looking at this top animated MRI, all you're seeing is moving anatomy, right? Physical structures in the body that are moving, like this beautiful heart that's beating. And in fact, there have been some innovations using MRI to show some of the movements in parts of the body that don't even move all that much. And so, some conditions result in elevated movements of the brain, for example. So here's an example. You might recognize this from a video that went fairly viral, like 2 times a while ago. So what we're talking about here is Chiari malformation. So that is a condition where the growth of the brain results in an occlusion of the spinal canal, which can result in basically poor flow of cerebral spinal fluid, which is basically just like the saltwater fluid that bathes the brain and circulates through various regions of the brain. And, as the name implies, it circulates through the brain and the spinal cord. and cerebral spinal fluid, right? And it needs to be able to flow through both. And so Chiari malformations prevent that flow, and it can result in a variety of biological and health challenges. And in fact, MRI has even been used to show that a condition called Chiari malformation may result in even greater movement of the brain during heartbeat. And so, while there's a bit of movement in the brain as a function of heartbeat in people without Chiari malformations, this study suggested that the anatomical differences that result from the malformation seem to produce even greater movement throughout the brain, which may explain at least some of the challenges that result from the condition. And so I'll be honest, like at least a part of the reason that I brought this up is that this video went viral, like 2 times again, of this brain jiggle is what it was often called. But without exception, the viral videos included the wrong videos and conveyed, therefore, the wrong interpretations, even in fairly scrupulous science like journalism outlets. And so the video you almost certainly saw was this one. And so despite what all the articles suggested, neither of these brains are like normal. In other words, both are of somebody with a Chiari malformation. And I'm talking about the top one here. And you can sort of tell, right, just by like the positioning of the head, that these are 2 different brains. This is the same brain. And so this video on top is just comparing how good their innovation on MRI was at capturing some of the more the subtler movements of the brain. And so, I'm sure it's super interesting to dispel misconception of a viral video from like 2 years ago, but I couldn't help myself. So anyways, we can create these beautiful animations of the body using MRI, but once again, I want you to notice that everything you're seeing that's moving is a physical structure within the body. While you are seeing the brain, you're not seeing like signals between neurons within the brain. And so, when it comes to conditions that arise from physical problems, something like MRI is excellent. But when it comes to how various things like drugs or psychiatric conditions or like specific tasks like making a decision or being exposed to various like images, MRI won't show you any difference. With an MRI, your brain is going to look identical before you've been shown a picture of someone like getting kicked in the face as it will right after you've seen such an evocative picture. And so, being exposed to images or making decisions doesn't change your brain anatomy moment to moment. And so an MRI won't reveal how brain activity changes in response to these conditions. And so, as a result, we need to use a technology that can give us some readout of moment-to-moment changes occurring in the brain. And so functional MRI or fMRI is one of the alternatives that can show changes in what it really shows is how much blood is being delivered to any given region of the brain over the course of seconds, basically. And so here, okay, let's Okay, here's an example of what a typical fMRI readout looks like. And so, there are plenty of like good criticisms of fMRI, which by the way, actually tend to come from people in the domains of neuroscience within which I work, where we focus more on like the activities of specific populations of neurons within specific subregions of the brain. So a much more granular interrogation of the brain. But, all of us appreciate the power of this technology to help us bridge the gap between just brain activity and the internal experiences of consciousness and the environment. And so back to the study of meditation. And so as they note in their publication, meditation is a pretty broad term that can refer to a pretty broad variety of practices. And, they explore a few different definitions of various categories of meditation practices like focused attention, open monitoring, and compassion. So, right, these are like 3 broad categories of meditation that they're referring to. And so in their study, they're focusing on a particular practice called transcendental meditation, often referred to as TM, which is, at its simplest level, can be basically considered like a kind of a subset of focused attention practices. And so, I should note here that, by no means am I like an expert of meditation. I took a class on a slightly different practice called mindfulness meditation. And so TM shares some features with mindfulness meditation, but they also kind of depart from each other in pretty substantial ways. Even though like somebody doing TM and somebody doing mindfulness meditation would probably look almost identical, like if you're just watching them, but it's what's going on in the inside that distinguishes them. So TM began in the 1950s with ties and origins in Hinduism and uses a mantra or a sound to control drifting attention. It doesn't necessarily even have to be an external sound, but just like imagining a sound even works or can be employed. And, mindfulness meditation, by contrast, tends to emphasize things like focusing on your breathing or sensations in various parts of your body, even the sensations of breathing. And so, then you sort of wait for the moment that your mind starts to kind of go wild because, believe it or not, focusing on what it feels like to breathe is not particularly captivating. And so that it can be quite challenging. And so it's kind of tough to describe what the first time trying out mindfulness meditation feels like, at least for me. But it's sort of like when you're in bed and you're trying to sleep, but your mind and body just like are not cooperating. You're super restless. And even though you have this goal of focusing on going to sleep, something about your consciousness is forbidding you from reaching that goal. So it's kind of like that. It's like this cognitive restlessness that you begin to experience. And, it's worth noting also that TM, transcendental meditation, is a more kind of formalized, standardized instruction process where you're supposed to sign up for a class and learn from an instructor. And, there's a price associated with doing so. And so it's perhaps a bit more standardized than mindfulness meditation, because mindfulness meditation isn't associated with like a particular school, like TM is a particular school, or a payment structure. And so, there are a ton of free resources available to help start trying out mindfulness meditation if you're interested. But the point here, relevance here, is that it's not quite as standardized. And so, independently of the various merits of the two practices, whether or not one is superior to the other in accomplishing their goals, an advantage to a neuroscientist who's interested in studying the effects of any given meditation practice on the brain is that TM is more standardized than just mindfulness. And so as good scientists, we do our best to control for as many things that might influence the outcome of an experiment as possible. And so, in other words, if you're trying to figure out the effects of meditation on the brain, and you go and you collect 30 people who are all technically meditators, and they all sit in one place, motionless for 30 seconds at a time, but some of them focus on the breath. Some of them repeat a mantra in their minds, like Om, something like that, or whatever. And then some of them picture themselves walking on a beach at sunset. Some of them picture achieving their wildest dreams, right? Or some of them, picture experiencing the greatest possible ecstasy that they can imagine, right? These are all radically different cognitive processes when you get down to it. And so, if you're watching this room of 30 people meditating, they'll all probably look identical again, right? Except maybe the ecstasy people, maybe like you'll see some smiles or something coming from them. But cognitively, it's very likely that different parts of the brain are being recruited across these different kind of approaches to meditation. And so, it helps to recruit a group of people who all practice a similar form of meditation as possible. And that's what this group did by focusing on TM. Again, that's transcendental meditation. And so past studies have shown that various meditation practices, not just TM, can be associated with improvements in self-perceived levels of anxiety, depression, and stress. So these are past studies. And some studies have correlated these improvements with various biological readouts, like stress-associated hormone signaling. So, there are some tangible data into which we can like dig our toes when, trying to move forward to understand, the effects or the relationships between meditation and the brain. And so they've also, in the study, they also note that past studies have scrutinized the effects of practices like mindfulness meditation or goal-directed meditation practices more broadly within the brain, and have highlighted regions within an anatomical network of brain regions, right? So it's like a constellation of brain regions that's pretty regularly interrogated in cognitive neuroscience. It's probably one of the most widely studied things in cognitive neuroscience, and it's called the default mode network. That's the term that we use to refer to that constellation of brain regions, and it's usually just initialized as DMN, default mode network. And so you can see a depiction of the default mode network here. These are three different approaches to the brain, but it basically refers to a constellation of different regions all throughout the brain that tend to be most active when you're not like focused on any specific task, or you don't have like a point of focus. That, it's like when you're daydreaming or just kind of like zoning out or letting your mind wander. But it can also be associated with like introversion, right? Thinking about yourself, or remembering like past experiences. And so, there are a bunch of regions that fall under this umbrella of the default mode network, but typically you'll see the following structures: the posterior cingulate cortex, or the PCC is often abbreviated or initialized as being. So the posterior cingulate cortex, the medial prefrontal cortex, and the angular gyrus. But again, there are other regions like the hippocampus and so on that can also be implicated in this constellation. And so the yellow regions that we're seeing here, we're seeing a side view, a front view, and then a bottom view. And so, and then, okay, so the structures from left to right, and I'm going to be referring to this one here on the bottom because it's the easiest to see all these structures. So from right to left, you're seeing so from this side to that side of it, you're seeing the prefrontal cortex first, then the posterior cingulate, and then the angular gyrus, which is on, like the angular gyrus is on either side of that central posterior cingulate cortex. It doesn't really matter where these structures are. It's just to give you an idea of like how disparate these structures are within the brain. It's a disparate constellation of structures, and so that's like one of the important sort of neighborhoods within the brain that this study, as well as past studies of meditation, have highlighted. And so this study focused on whether there were detectable changes in baseline patterns of brain activity following 3 months of a transcendental meditation practice. And they also, conveniently, did an assessment of whether there were changes in the psychological experiences in these same people. And so in particular, they found that there was an increase in what's called functional connectivity between specific components of the default mode network. So, and I've brought up like a fairly obnoxious level of jargon already, but functional connectivity refers to a fairly simple concept. So basically it's just how likely is it that different and distant parts of the brain are to be communicating or influencing one another. One part, if a bunch of neurons in one part of your brain are active when you're just like sitting there minding your own business, and it turns out that neurons in a totally different part of the brain are also active, coincidentally, then it might be the case that those brain regions are influencing one another in some way. And so it turned out that this group found that there was a correlation between people who followed the TM, the meditation practice, who reported an improvement in their own psychological well-being, things like anxiety and depression and stuff like that, and an increase in the functional connectivity of their default mode networks. And so they hone in on very specific components of the network. And I always hesitate to rattle off like names of brain regions because it's not particularly edifying. But, particularly when I've already said so many, so jargonous, when there's so much jargon already included. But I know that some people are interested in hearing them. So they noted increased functional connectivity between the precuneus and left parietal lobule, as well as increased functional connectivity between that posterior cingulate cortex and the right insula. And so they interpret this as indicating a change in the balance between interoceptive and external awareness. But I think it's worth noting that this is extrapolation on their part. It's pretty justifiable, derived from past studies of these brain regions. Both the posterior cingulate and the insula are among the most widely studied brain regions in the human brain for sure. And I'm not necessarily an expert in either of these brain regions, but I certainly had to study them, as any PhD student in neuroscience would have to. And that interpretation definitely comports with what I would expect anybody else to speculate. And as with any reasonable study, they note the limitations of their own study. So most significantly, it's a fairly small sample size of people who were involved. But most meditation studies aren't like this one. They often, typically evaluate differences between people who either do or don't meditate at a moment in time, cross-sectional. Now, another issue with this study is that it wasn't randomized. Their sample of participants wasn't randomized. People were just able to elect whether they meditated or did not. And another potential issue with this study is that all the meditators didn't necessarily spend the same lengths of time meditating. And so it's not necessarily clear that more time meditating delivers more nutrition derived from meditating. One might argue that 15 minutes of meditation is better than none, and maybe 30 minutes of meditation is better than 15, but are we really sure that 60 minutes or 120 minutes, an hour, 2 hours is better than 30 minutes? I haven't seen any data either way. Okay, so we just have to factor that into our interpretation. As standardized as it was, they were all doing the same kind of meditation. They weren't necessarily doing it for the same length of time over the course of that 3 months. And so another interesting potential limitation of this study is that a meditation, it might be the case that just a meditation practice enables you to settle down and relax in the strange environment of a gigantic donut of the fMRI machine for extended periods of time while strange people assess your brain activity. You might just be able to be calmer specifically in that setting. And so and then as I said, participants it wasn't a randomized sample, so participants were recruited by word of mouth, according to the study. And that doesn't necessarily mean that it's terrible, but there are better ways to recruit study participants. It could be the case that the people who are most likely to receive the news about this study on meditation were those who were already most interested in meditation to begin with. It's not necessarily the case, but it's possible. And, I don't necessarily think that's totally meaningless, right? Perhaps it just means that they're better able to relax in strange settings in general. But, it's just something worth considering. And so what made this study interesting to me, though, despite these limitations, is that they followed the same group of people over the course of 3 months. And so they could compare changes occurring within each person. So they could compare changes in one person over the course of that 3 months. And so that's like a super useful feature of a study that's interested in the potential effects of any given treatment on a person's brain over time, right? You can follow changes within one person. And so, overall, what this study showed was that self-reported levels of anxiety and stress were reduced in those who practiced the meditation. Oh, and then to quote Giulia Avenuti, who's a PhD fellow at the IMT school, which is the institution that conducted this study. And she's also, I assume she's a she, she is also the first author. She said, magnetic resonance imaging also shows that the reduction of anxiety levels is associated with specific changes in the connectivity between cerebral areas, such as the precuneus, left parietal lobe, and insula, which all have an important role in the modulation of emotions and inner states. In the control group, instead, none of these changes were observed, right? So that's like the crux of the study. And so before we wrap this up, before I dove in, I suggested there's a little bit of a twist. And there's a weird twist to this study. It turns out that part of this study was funded by the David Lynch Foundation. And so, I suspect most people who might see this might be totally unfamiliar with David Lynch, but he's someone who's been involved in like pretty famous in influential movies and TV shows, and it's interesting that he's associated with meditation because like these TV shows and movies are usually kind of unnerving and strange, and definitely worth watching. But we're talking Blue Velvet, Twin Peaks, Eraserhead, Mulholland Drive, and a movie based on Dune. Not my favorite Dune movie, but yeah, he did it. And a lot of memes were generated before there was even like meme culture from that movie. So yeah, these are kind of weird movies. But he has been this devotee of transcendental meditation now for many years. And so, just because a study derives their funding from a specific person or a specific group or entity doesn't necessarily mean that the study is compromised. It was published in a peer-reviewed journal, and so the peers of the scientists who conducted this study were incentivized to discover weaknesses in their science. But it's still just like an odd twist that you don't typically expect to see David Lynch show up in a study of meditation. Okay, so that's what I have for you today. Let's see. Did I not have? Oh, that's too bad. Okay. So let's start the live app. Oh wait, nothing wrong with jargon. Yeah. Thank you for being here despite your crappy week. Did you meditate to cope with the stress of it? I didn't actually. I probably should have. But yeah, good idea. Maybe I should when we're done here. Okay, hello everybody. My name is Ian McLaughlin, and I'm a PhD in neuroscience. It's still weird for me to say that at the University of Pennsylvania. And I just did about 15 minutes or so on a study that came out about meditation, specifically if there's some relationship between changes in patterns of brain activity and changes in self-reported levels of anxiety and stress and depression over the course of 3 months. Of people who either practiced a certain form of meditation called transcendental meditation or people who did not. Hello, Bob from Oakville. Good to see you. Hello, Joy and Sherry. Nice to see you both too. Let's do boop, boop. Oh yeah, let's do this. It's much easier for me to see the comments like this. And here we go. Let's hope the sound is off. Of course it's not. Okay. So, what's up, guys? Hey, Leonora. Hello again. Yes. Okay. More jargon, please. Yeah, I mean, a lot of the like cognitive neuroscience jargon. So I talked about, it was a cognitive neuroscience study where they used fMRI to see if they could detect changes in the brain over the course of meditation. Yeah, so I had, I talked about like the posterior cingulate and the default mode network and what fMRI is, what MRI is. Oh, and I also sort of debunked a video that kind of went viral a while ago. It kind of had like two kind of waves of virality that showed like the brain jiggles a lot in the skull. But there was like a sort of critical error in how those videos were spread and how they were interpreted. Specifically, like they showed a video, and you can I have it on the YouTube. You can check it out. You can find the YouTube by searching for like Ian Brain Anthropoid or something like that. You'll probably get there. But they have this video. Oh, you know what? Actually, such a goofball. I could show it to you. I forgot I did this. All right, let's see if you can see this. So can you see that? I don't know if you can see the brain jiggling. Yeah, so I talked about that video, and I corrected the record a little bit because the videos that went viral suggested that both of those brains, both of which were moving a bit, were just like a normal brain in the same person, and they just did some like magic, and they were able to detect this change or this greater movement than we thought. The problem is that both of those brains were of people of a person who has Chiari malformation, which is like an anatomical abnormality that can occur. And the study that produced it was a very important study that produced these videos did have videos of somebody without Chiari malformation compared to somebody with Chiari malformation. And the whole point of the study was that it turns out that Chiari malformation results in even greater movement in the brain than somebody without. But the point is, what you're seeing there is like the amplified degree of movement in somebody with Chiari malformation. So you can check out like an accurate comparison of somebody without Chiari malformation and somebody with, and it is true that somebody with Chiari malformation has more movement. Wasn't there a study on Christians praying in tongues? Wasn't there a study on Christians praying in tongues and what part of the brain was activated? Yeah, there have been over the years like some really interesting studies on various like spiritual traditions. Like I remember there was one that was kind of interesting, which was like evaluating, and I think this was like several decades ago, but there was a study that evaluated how the effects of psychedelic hallucinogens, I believe they used psilocybin in this case, how the effects manifested differently in people who were spiritual, like literally like members of the clergy, versus people who were secular or agnostic atheists or whatever. And it turned out that people who were spiritual tended to have more religious like experiences or spiritual experiences while under the influence of the drugs, which it's perhaps unsurprising, but it's sort of like more evidence that set and setting affects the subjective effects of that category of drugs. Okay. So I seem to be forgetting a lot of long-term memories. Could it be because of trauma? So the word trauma could mean a couple of different things in that case. It could mean like traumatic experiences, which absolutely can influence memory, but it can also mean like injury, like head trauma, which also can influence memory. If it's sort of just spontaneously happening, I'm not a physician, I'm a scientist, but as we get older, we just generally do tend to have non-trivial, but not necessarily severe deterioration of memory. So that's natural. Generally speaking, it tends to manifest more with regards to short-term memory rather than longer-term, like very long-term memory. But I mean, if you feel like you're forgetting things like, if you're forgetting somebody's name in your family or something like that, that is, perhaps an indication that it's just worth talking to a physician. And if you're concerned, particularly if you did have past, severe adverse experiences or traumatic experiences, some recent studies have shown, well, not only recent studies, but some studies have shown that like, the number of severely adverse life experiences that a person has, particularly during childhood, can have pretty substantial ramifications for people's predispositions to various psychiatric conditions, most notably just addiction. The specific numbers are evading me at the moment, but this is generally the sort of ballpark of the numbers. There's a study that was done at Penn, which is where I work, that basically, it was like a large number of people coming into the clinic to be treated for addiction, and something like 80% of them recalled severe adverse life experiences, being traumatized, emotional neglect, physical abuse, and or emotional abuse, sexual abuse, these types of things, that tends to be quite enriched or quite a bit more common among people who are addicted to drugs. But that's not the only psychiatric condition that can be associated with traumatic experiences. I believe the stats are, if you have one adverse life experience, you are like 3 times more likely to experience psychosis as you get older. And if you have more than one, that probability increases. So I can't tell you for sure that, like, if you had a traumatic life experience, that is what's responsible for a deteriorating memory. It can be a lot of different things. And again, it does kind of happen naturally. All right, my question is, the Donald, is he nuts? And then I think you literally have a nuts emoji. I certainly couldn't tell you. Okay, to all the people watching, this guy has a badass beard, so he was twice as cool than other scientists. Yeah, I had to get rid of it because when I was younger, so I had like a barbecue blew up in my face, and like mostly this side of my face was quite burned. And so now it turns out, and I didn't know this, this is when I was like a teenager. And many, many years later, once my like facial hair started to grow in, it now, like, some of the follicles shoot out their hair in like wacky directions. And so it's not like symmetrical, it's sort of like asymmetrical. And it also got a little bit painful. So yeah. And also I'm sure my daughter prefers that I don't have facial hair. But can't tell you for sure. I guess we'd have to ask her, but she only knows a couple words at the moment. Okay. Hey viewers, check out Ian's YouTube. His office is backward compared to what you see on Periscope. Yeah, thank you very much for bringing that up. Yes, I have a YouTube channel. Still, pretty small. I haven't had enough time to like produce actually good videos, but anytime I go live here, about 15 or 20 minutes before then, I do like a specific topic. And this time it was a study that came out of Italy that showed interesting changes in a network of the brain called the default mode network in people who followed a specific kind of meditation practice, transcendental meditation, or TM. So you can check that out. Search like Ian Anthropoid Brain or something like that. All right. Yep, it jiggled. Working out or physical activity affecting the brain. Yeah, sure. So of course, there's different types of exercise, right? There's cardiovascular exercise. There's, you could basically group them into cardiovascular exercise and resistance training, weightlifting. And they both do have effects certainly on physiology. That's abundantly clear. But and for a long time, it wasn't completely clear as to whether or not there were like substantial cognitive benefits to cardiovascular exercise, which was kind of baffling to scientists, because it's like, we know that there are so many peripheral benefits. How could this not be beneficial to the central nervous system? And some recent studies showed that yes, indeed, specifically with regards to propensities for dementia. It was, it's funny, this has come up now, like, I think like 4 times in a row. That like 20 minutes, 3 times a week of cardiovascular exercise in particular was associated with improvements on people's propensities to developing dementia. So yeah, bad beard, not badass. Fair enough. Okay. He also looks like Ryan from The Office. We like him. He's the most famous scientist in Philly. Certainly that's not the case. There are far more senior and accomplished scientists in Philadelphia, particularly in Philadelphia, than I am. And I have had the privilege of working with some of them. But yeah, I can't focus or I get distracted so easily. Does it relate? So I guess I'm not quite sure what you're saying, what you're suggesting it might relate to. But one's ability to like maintain motivation and focus on any given specific topic is sensitive to a variety of things. So it could be sensitive to just how much sleep you've been getting. That's probably that might be like the number one thing that you haven't really considered evaluating. Certainly in America, I think we all broadly underestimate the value of sleep. But it can also be a function of, do you drink coffee typically? Have you not had any coffee? Coffee has like a specific effect on the very neurophysiology that kind of determines one's ability to stay focused on a given topic for an extended period of time, called the mesocortical limbic dopaminergic circuit. It's part of the reason for why ADHD medications are capable of improving people's people with ADHD their ability to focus on a task, because it's like cranking up the volume on that very specific, that same exact pathway. So yeah, okay. How do I get the app, Kids Play app, not charge my daughter? I'm not quite sure what you mean by that. What do you know about the pineal gland? Well, I know a fair bit. So, in fact, the brain region that I studied, or I guess I'm continuing to study, the medial lobennula, is anatomically quite close to the pineal gland. In fact, for a long time, it was considered to be a part of the pineal gland. But it is distinct, and it's much, much more interesting. So the pineal gland is this tiny little nugget, sort of right at the top of the thalamus, that has gained like sort of supernatural or disproportionate relevance societally, and it's not particularly justified. There are some interesting things about the pineal gland, though. So, namely, a lot of people refer to it as the third eye, and for the most part, there's no good reason to refer to it as that, except anatomically, specifically phylogenetically, meaning if you look at this brain structure in other organisms to which we're evolutionarily related, even quite distantly, what is likely the equivalent of their pineal gland actually does tend to resemble an eye a little bit more than it does in our own brain. It is also the case that the pineal gland receives signals directly from the retina, from photoreceptors. In particular, how much blue light we're exposed to. The baby's back from her walk, by the way. And so it does have some relevance to light associated processing and visual, stimuli. But it itself is not participating in the perception, or I should say the sensory perception of light, apart from the fact that it can help to determine or entrain our circadian rhythm. That is like the main business of the pineal gland, is to help us to entrain our circadian rhythm according to how much light we're exposed to, and in particular, how much blue light we're exposed to. But apart from that, there is no good evidence that, like one of the sort of the biggest, it's not quite correct to call it a myth, but it definitely is a bit of a myth. So there is this myth that the pineal body or the pineal gland produces high levels of a psychedelic hallucinogen called dimethyltryptamine. And there's a kernel of truth to that, because studies have found trace levels of dimethyltryptamine in the pineal gland. But the key word there is, right, so yeah, that last line, 77, it releases DMT-like substance too, right? So no, like there's no evidence to suggest that DMT ever reaches concentrations anywhere in the brain that are like relevant for broad signaling patterns. And there's certainly no evidence that dimethyltryptamine is produced at significant levels during like a near-death experience or when we're dreaming. And in fact, we really don't need to invoke any drug, any dimethyltryptamine or anything else to explain the conscious experiences that people have when they're near death. Keep in mind they're near death; they did not die, or certainly when we're dreaming, and so that is sort of like one of the primary. I hesitate to call it a myth because there have been trace levels of DMT found in the brain, but they're trace levels, so it's not like playing a role of like neuromodulators or like neurotransmitters like serotonin or dopamine or so on. If it plays any significant role, it might be in like influencing intracellular dynamics, but not like what happens when you take massive doses of DMT and then experience psychedelic hallucinations. I have PTSD and can't figure out how to get my life to a functioning place like other people, normal. Whom I? Well, I'm sorry to hear that, and I hope that the reason that you say that you have PTSD is because you've seen a psychiatrist or a psychologist, a mental health professional who has recognized that condition in you. And the best way forward, whenever you are, the best tool that we have available to us as modern humans, as Homo sapiens sapiens, whenever you're suffering any kind of mental health difficulty, any mental health challenge, is to go see mental health professionals. I understand that some people hesitate to do that for a variety of reasons, not the least of which being a stigma associated with going to see a mental health professional. And perhaps some of it is a little bit of anxiety that if you are going to a mental health professional for any reason, you have now like formalized that you have this issue. But the reality is PTSD is a very significant psychiatric condition. And, you know, rates of suicide in the United States are increasing. And you know, there are people who have devoted their lives to helping people in positions like yours, or people who are suffering, you know, psychiatric conditions, helping improve their quality of life. And there are, PTSD in particular, there are some medications that can help to attenuate the severity of PTSD. So yeah, I mean, that's the best way forward. Okay, why do my farts smell like hot garbage? That's a funny question, but it is a good question, believe it or not. And I know you're probably trolling, but there is an answer to that question. So why does flatulence smell so bad? There's a bunch of different ways that we could take this, believe it or not, if you're a neuroscientist. These are the types of questions you can ask, or a biologist. So first of all, the actual content of flatulence. Why does it smell the way it does? It's a byproduct of the microbial populations that inhabit your gut, and your gut is unique in the constellation of those microbes. So your gut is like a snowflake, right? And so, you know, different people have different microbial populations that live in their gut. And why does that matter? It's not like you're farting out bacteria. No. Why it matters is that those microbes interact with what you eat, with what is being introduced to your intestine, convert it to other molecules, and in some cases, those molecules have an odor to them. And depending upon what nutrients you're exposing to these microbes that inhabit your gut, you will be more or less likely to produce, you know, certain, let's say, odorant signatures. Okay, but there's a deeper question here. Why do those things smell bad to us, right? You know, there's a bunch of different smells in the world. Not all of them smell bad. Some of them we actually like quite a bit. Like, why is it that every soap has to smell like lavender? And, you know, why is it that, like, you know, Axe body sprays, you know, or, you know, all, like, most colognes all kind of smell the same? Well, let's focus on the easy ones first. So first of all, why do certain foods smell so good? Like, you know, when bacon is cooking, you can smell bacon. If you like bacon, you're like, ooh, that smells delicious. Or popcorn, or, you know, sort of like classic smells. Well, the reason that registers as positive is that you know that smell is associated with a food that is delicious, right? So you have this olfactory sensory association with that thing you're smelling. Okay, so that's obvious, right? You don't need a neuroscientist to tell you that. But then why is it that farts or garbage smell bad to us? Well, if you think about it, early on in human evolution, even before Homo sapiens evolved on the planet, right? Olfaction is one of the most ancient and therefore most unique sensory processes that inhabits our brain, or that comprises our brain. There are some biologists, scientists, who argue that it might have been the first sensory modality that evolved ever on Earth, because at its core, what it is a given molecule, you know, in the air or in the water, just sort of swimming around, you know, the substrate of the planets, and hitting a receptor. In our case, it's, you know, olfactory receptors, and then causing some kind of change that occurs in the brain. Okay. So before we even had language, right, before we had significant, you know, human civilization, we still needed to navigate a world where some things were beneficial for us to consume and some things were life-threatening to consume. And so, you know, so if you consume berries or, you know, bacon or whatever, that's great. You know, it gives you sustenance, gives you nutrients, and so on. However, if you consume garbage or rotting flesh, rotting meat, or the main thing from which farts get their smell, fecal matter, that can be life-threatening to you. And so as a result, we have this handy-dandy system in our brain that enables us to just instinctively know this is going to be bad for me, and this might be good for me. And that's why farts smell bad. Not only why they smell bad, but why yours smell so bad. See, we have a lot of fun here over on the Anthropoid channel. Oh, we're getting a call. And so our good friend Chris in San Francisco, what's on your mind today?
What's on my mind? Let me just be succinct. Less and less hair.
Well, that's actually a good thing. You wouldn't want hair on your mind, but I
Yeah.
I understand what you mean.
Yeah. Speaking of garbage, I have not had any fast food in 1 year and 2 months.
That's almost certainly for the best. Is that like an intentional decision that you made?
Yeah, it was a New Year's thing, and I just said I want to do this with God's help. I said I don't want any more fast food. Twice I put fast food in my mouth accidentally, and I spit it out. And yeah, but other than that, boom, no fast food for a year and 2 months.
Have you noticed any kind of changes?
Yeah, more money.
Well, have you lost any weight? Like, was that part of a goal of like losing weight or anything like that?
Yeah, I am losing weight, and I feel much better. Yeah, definitely, definitely.
Did you have a favorite kind of fast food?
Free. No, yeah, I would eat indiscriminately.
Yeah, you're an equal opportunity eater. Well, congratulations, man.
And then also, I have not had any soda, any soft drinks in about 15 years.
Now, that I think, fast food, there's arguments that it's almost certainly bad for you. But soda, I think in America is like almost certainly causing a substantial component of the public health crises in this country, like diabetes, metabolic disorders, overweight, just being overweight. When I was growing up, I used to like only ever drink soda. I don't think I drank water ever for like years.
Same here. Yeah.
Yeah, and like I had these like canker sores and like I had like not ulcers, but like the predecessor to ulcers. But I was just drinking the soda all the time. My favorite was Coca-Cola or Sprite, root beer every now and then too. And so yeah, at a certain point, like I decided to get into weightlifting and blah blah blah, and I just stopped drinking soda. And I, like you, haven't had soda now for many, many years, not even diet soda. But like I'll sip it every now and then, just to taste it, like treating it like the candy that it actually is. And oh my God, it's like mind blowing how sweet it is. It's like drinking chocolate syrup almost. It's so wild how desensitized you get to it.
Exactly. Well, my quick question, I'll hang up to hear your answer, is this. I'm taking I've taken a couple of yoga classes.
Mm-hmm.
And is there any such thing, or is there credence to this statement, mind over matter? I'm just curious. I'll hang up to hear the answer. Thank you.
Love it. Okay. Yeah, great topic. So first of all, Chris, you might be interested to know that over on the YouTube channel, I talked about a new study that came out of Italy that showed interesting changes in a specific constellation of brain regions in the brain called the default mode network in people who practiced 3 months worth of a specific kind of meditation called transcendental meditation. It's an interesting study, blah, blah, blah. But, obviously transcendental meditation or even mindfulness meditation isn't the same as yoga, right? Yoga obviously has this much more, body associated component to it. But I think it's safe to argue that there is a meditative component to yoga. Certainly a ritual component to yoga, but I think it's safe to say that there is a meditative component to it. So mind over matter, that's a huge topic. I think people use that phrase in a bunch of different ways, right? Some people use it in a much more like metaphysical way, like perhaps we can move things with our mind. There's at least I've never seen any evidence to suggest that that's the case, apart from using your mind to cause your hand to move matter, right? But the degree to which your like experience of your body is influenced by your mind is very substantial. So like for example, I can't remember, I think I was just having a conversation with a friend of mine in the lab. And we were talking about like the emotional component of pain. And so, pain is like, it's like it's obvious what its evolutionary benefit or purpose is, right? It's to identify causes of damage or damage to the body that might be life-threatening. And therefore it's obviously important for it to be aversive, and to motivate you to engage behavior to eliminate the pain. Right. But like, and so there has to be an emotional component to it. And in fact, the same structures that regulate pain also can regulate emotion. It's part of the reason for why heroin, morphine, oxycodone are so addictive. It's like almost the same identical system, slight differences, but okay. So like what is actually going on cognitively when somebody is in pain? Right? Like in the moment that something is causing you pain, let's say, my daughter is pinching my arm as she is wont to do. In that moment, I know that I'm surviving, right? Rationally, I know that I'm not going to die. And so it is almost this like, it is the anticipation of continued damage and the emotional like fear that this is not going to stop and that it could get worse. That is sort of like amplifies the aversive component of pain. And that's obviously completely cognitive. That's purely mind. And there have been studies, and some of them are pretty funny. Like there have been studies that showed that when you put somebody in an environment where they're exposed to some kind of controlled source of pain, one of them, for example, is like if you have a bowl of ice water, like super, super cold water, and they put their hands in the ice water, and then you measure just how long can they tolerate that super, super cold water before it becomes too painful and they have to withdraw their hand. Well, it turns out that if people utter profanity, right? If they're cursing, in other words, while that's occurring, they're capable of tolerating greater lengths of exposure to pain. And that's that has nothing to do with like anything changing the biology of the hand. It's purely mind. And so there are like various studies like that where a very specific change occurring in the mind influences one's experience of their body. Certainly. Oh, and then there is I think there is something to it for sure. Obviously, I think the brain is the most important part of the body, but obviously it governs so much of the body. Oh, and another great example is. You might even call it, the placebo effect, but it's not even necessarily the placebo effect. If a person is undergoing some kind of treatment for a lot of different things, and they really truly believe that their treatment is working to combat whatever their malady is, they are much more likely to improve. Right? If somebody is totally pessimistic that nothing is going to work for them, that like the rates of improvement are lower. And so that's purely just optimism, just believing that this is going to work. And, even beyond that, like, mood states influence the immune system, right? If you're highly, highly stressed or, chronically stressed, that is associated with immunosuppression, right? Through glucocorticoids. Cortisol, you might have heard of, is immunosuppressant, anti-inflammatory. And so there are, a handful of lines of evidence to suggest that yes, there is something to the concept of mind over matter, but that doesn't extend to like the more sort of metaphysical claims that people make. Oh, and thank you so much for the super hearts, Sherry. Oh, and thank you, Chris. It's very generous of you. Okay. That's my daughter. Is magic mushroom good for the brain? Well, unfortunately, it's not that simple. It's usually never that simple when it comes to drugs. So, I think a more productive question would be, are magic mushrooms, psilocybin-containing mushrooms, any better or worse than other drugs that people do recreationally? And let's focus specifically on recreational drugs. Alcohol, tobacco, put cannabis in there, or even coffee or caffeine. If you compare it to maybe, of all those drugs, perhaps alcohol is it induces the greatest altered state of consciousness. Like coffee does alter your state of consciousness, caffeine, but it doesn't it can't completely inebriate you to the point where you can no longer function. And the same goes for tobacco. Of course, tobacco has other problems that don't have to do with its psychoactivity, but magic mushrooms profoundly alter your state of consciousness. So if we compare it to alcohol, is it better or worse? I have never seen any evidence to suggest that psychedelic drugs in general, but specifically psilocybin-containing mushrooms, induce the kind of damage to the brain and the body that alcohol does. I think it makes sense for us to compare apples to apples here. And, is there any evidence that psilocybin-containing mushrooms are good for the brain? I think that's a hard argument to make, except for in the instances where it's being evaluated as a potential psychiatric tool for the treatment of it's funny, this has come up quite consistently too, but terminal life, or terminal cancer, things like that, where people are confronting an imminent demise, a depression obviously is understandably can be associated with that. And psilocybin has been shown to be beneficial in that case. And so, you could make the argument, okay, then maybe that's an argument that they can be good for the brain. Maybe, maybe not. Another interesting pharmacological effect of psilocybin is in people who have migraines. Or actually, I think it's actually cluster headaches, but I think also migraines, where, unsurprisingly, if you know the neurochemistry of psilocybin, it turns out that folks who suffer those headache-associated conditions can attenuate the severity of their headaches with psilocybin-containing mushrooms. People have and not necessarily like psychedelic doses of psilocybin, so they're not like having a hallucinogenic experience necessarily, but it's helping to reduce their the propensity for having those headaches, which can be quite debilitating. So now those headaches are not inducing any damage to the brain, but it is a source of considerable suffering, and so anything that reduces that suffering, I would argue, is beneficial. But yeah, interesting topic. Mushrooms are illegal though, but helpful. I think, wasn't it Denver? I think Denver has decriminalized, I believe, psilocybin. I think so. But that doesn't mean that it's legal, that they're legal to the federal government. In New York, they have a mushroom pizza called fungi pizza. Yeah, I know. That's my favorite kind of pizza. Can you really go blind from choking the chicken? No. How dare you bring that up in my daughter's presence? I have constant pain from back injury causing depression. I hate to take narcotic pain pills. Music Man, I'm sorry to hear that. I mean, that is, you're not alone. Chronic pain is very closely associated with psychiatric conditions like depression. And it makes sense. Like I just brought up, the relationship that opioid signaling, the mu-opioid receptor in particular, has in modulating pain. That's why we use painkillers like oxycodone or morphine, but also regulating emotion. And so, that is an indication that the same system that's regulating pain and regulating emotion, there is this emotional component to pain that arises from that neurophysiology. And so therefore chronic pain is recruiting a lot of the same parts of the brain that are associated with mood, and particularly aversive components of mood, because pain is aversive. And so, yeah, I'm sorry to hear that. And also that you expressed that like you hate taking, narcotic painkillers or, opioid painkillers. That is also not uncommon. I think there is a misconception that people universally, no matter who you are, will enjoy opioids. And that's just not the case. In fact, most people who are exposed to opioids never develop an addiction to them. And a pretty substantial contingent of people find them aversive. They makes them nauseous, makes them dizzy, makes them feel cognitively sluggish, and they would rather not take it. One of my parents responds that way. The other of my parents does not. And I know in which bucket I fall. But yeah, I'm sorry to hear that. I'm sure it's cold comfort to somebody in your position who's dealing with this today, but there is a very substantial effort within neuroscience to devise completely novel solutions to pain because of all the issues that opioids present, right? Opioids are extraordinarily useful drugs. They're, interestingly, they don't damage the nervous system, but of course they're severely addictive for some people. And they're in fact not all that effective for chronic pain, unfortunately, because of the adaptations that occur in the brain that require escalating doses of painkillers. And opioids really don't regulate the kind of, pain neurophysiology is very complex. There's like the quick pain that you experience when you step on a Lego, let me tell you. But then there's also and that pain is transmitted via unique projections that are not the same as the kind of pain that you experience when you have like a toothache or a bruise or chronic inflammation in the back. That's a different kind of pain pathway, and opioids are not as effective at reducing pain from that neurophysiology. But unfortunately, there aren't a lot of other alternatives available. I forgot to ask, Pat's Gyms or Geno's fast food? Honestly, I still haven't tried any of them, which is wild, I know. A friend of mine came up and was like, man, like, how have you not tried this? You can't even tell me. My favorite is Denick's roast pork in Reading Terminal Market. If you ever come to Philly, don't worry about those cheesesteaks are gross. Just in my opinion. There are the best sandwiches in the world here in Philly, but they're not cheesesteaks. They're Denick's. It's a pain of being an Eagles fan. Any effective for trigeminal neuralgia? Share McKee Mouse. I feel like I recognize you, don't I? Yeah, I must. Oh wow, drone pilot, cool. So not so there's no like I'm not aware of any like particularly effective pain treatment for the pain that arises from trigeminal neuralgia. For anybody that's not familiar, that is an extraordinarily debilitating form of essentially chronic pain. It's not constant necessarily, but it's like it can feel like your head is on fire. Is how it's oftentimes described. Followed you for like 2 to 3 years. Oh, awesome. Yeah. Okay. I thought so. Oh, we were getting a call. Sorry, I missed you. Feel free to call back in. Can you describe the effect of repeated concussions from football? Sure. So, well, for anybody that's not familiar, if you're not American, football refers to American football, and it's, where you have that sort of oval-like ball and, a lot of padding and a lot of physical contact. Fairly recently, in the last couple of years, it has been, some physicians have noticed that there is a kind of consistent syndrome that can arise that tends to be enriched among professional football players. And it has become a little bit more controversial kind of recently, but, it has been sort of known within biomedical science that repeated injuries, repeated trauma to the head can result in a kind of dementia, essentially. It has been called recently chronic traumatic encephalopathy. It used to be called dementia pugilistica, or just being punch drunk, for example. And that was recognized in professional boxers. And basically, the statistics showed that like the more boxing bouts you engaged in, the more likely you were to develop that condition. And like the more you've done, the more severe it'll be. So what's happening when you have repeated concussions specifically? So basically what's happening when you're having a concussion is that the brain has moved, literally physically moved within the skull, bounced up against one side of the skull and sent pressure waves through the brain. And so, I think a lot of people think that the brain is this like physical, like really rigid, robust physical structure, and it's actually not. Almost without exception, any human brain you've seen has been what's called fixed, meaning that it has been treated with fixatives like formaldehyde, for example. It's usually not formaldehyde these days, but chemicals that do the same thing that basically lock molecules of the brain into place, forming chemical connections between them, cross-linking. And so as a result, it is just this like artificially hardened structure. But without that, it's really this extraordinarily fragile structure that if like somebody were to like scoop out my brain and set it on the table, it would over time just sort of, and if somebody like took their finger and just like stuck it into my brain, they'd be able to go in fairly easily, assuming that the brain is completely exposed. And so it is this sort of like gelatinous structure. And so when, we evolved to be able to tolerate certain G-forces, like, certain accelerations, essentially, but beyond a certain point, we just didn't evolve to tolerate that. Some animals have, like the woodpecker, for example, evolves. It's pretty wild, the anatomy. Their tongue, like, wraps around their brain, essentially, or their I guess, I don't know if it's their brain or their head, their skull, to sort of, like, add cushioning for them to smash their head up against a tree. But we don't have that. And so as a result, you have these pressure waves that propagate through the brain, and that pressure wave, that physical disruption of the structure of the brain, can result in rupturing of the connections between neurons. It can result in a rupturing of neurons themselves, causing them to deteriorate. And depending upon where that occurs, you can have different symptoms that arise. And just doing that repeatedly, exacerbates that phenomenon, obviously, because you have a greater probability that that's going to happen. In some cases, it has been shown that there are little aggregates that can arise in the brain of somebody who's repeatedly had head trauma, not even like subconcussive, not even head trauma that caused a loss of consciousness. And I mean, and not all concussions are the same. There's like three different kinds of three broad categories of concussions, where there's like like basically as a function of how long you lost your consciousness. But generally speaking, if you've had a concussion, that is a non-trivial insult to your health. But yeah, it's like a physical disruption of the brain. Okay, you could put all your asking questions in a huge book. So I've had an idea for a book now for a while. I might have just found somebody who might be able to help me. I just don't know how to publish a book. I had a head injury when I was 8 years old and have quite angry personality because could those be correlated? Absolutely, they could be. I can't tell you for sure that they are. Some people have, for whatever reason, some combination of environmental experiences and their own unique, neuroanatomy are predisposed to greater levels of aggression. And so, it's not a necessary component of aggression to have a head injury. But it has been shown that repeated head trauma can be associated with increased aggression and like disrupted behavioral inhibition. In other words, like, a disruption of your ability to like inhibit some of the more primitive urges that we experience, like wanting to, eat all of the ice cream in the freezer, or wanting to go gamble or engage in risky sexual behavior. So yeah, they can be connected. Okay, we are getting a call from, I think, Clements. Oh, well, what's your name and where are you calling from?
Clemency for Ricky, calling from 18th and Lombard.
Are you serious?
Right across the street, apparently. What's going on?
Very cool. Not much. What's on your mind?
Not much. I just want to say hi. Thanks for taking people's questions and doing what you do, and appreciate listening to you.
Oh, well, I appreciate it, man. I hope you enjoy the...
That's all I got. I've got no mental question for you. Just wanted to say hi, neighbor, and hope you're doing well.
That's awesome. Well, enjoy the beautiful day that we have. Thanks for calling in, man.
Take care. Bye.
That's pretty cool. A fellow Philadelphian in Center City. Okay. Does your knowledge of potential brain injury dissuade you from spectating certain sports? That is really interesting. So I've never really been a huge fan of watching football. I played football and I had concussions. I have been more of a fan of mixed martial arts. That if there's any sport that's going to be associated with a risk of, injury to the brain, it is mixed martial arts, specifically striking. Not necessarily the case with jiu-jitsu or Brazilian jiu-jitsu. It's more like submissions and that kind of stuff. But like striking is obviously quite common in mixed martial arts. And at a certain point, either somebody's trying to choke somebody out or cause them severe pain or deal enough damage to the brain that somebody loses their consciousness. Yeah, Conor McGregor is a great example. He is a striker, striking-based kind of guy. Yeah, I mean, it is like, I don't watch it like religiously at all. There are certain fighters that I've always liked since I was like a kid, basically. Uriah Faber has been one of my favorites. And he also was like very striking-based, although he's also a wrestler. But anyways, yeah, I mean, I do certainly experience this moment of like what I'm watching is two people making a gamble as to whether or not they can deal enough damage to the other person's brain before that person deals damage to their brain. I mean, that is, fundamentally what you're seeing in boxing, but also in a lot of mixed martial arts. But for me, like, I don't think that engaging in behavior that has some risk of brain injury should be like made illegal or is fundamentally unethical. I just think that it is only ethical if everybody engaging in the activity is aware of the risk. And so, for example, like, even when I was in high school and playing football, it wasn't entirely clear that, that this had long-term consequences. Like, yeah, it was an injury if you got a concussion, but it wasn't like, that you're going to pay for this when you get older. And now it's abundantly clear that that's the case. And beyond that, high schoolers, adolescents are even more vulnerable to concussions than adults are. And so I can tell you that it has, made me confident that if any of my kids ever want to play football, they're not going to be allowed to. But that's mostly because there's really no upside to them doing that sport over any other because, like, believe it or not, I don't have the genetics of a professional NFL player, right? Even though I did play running back and cornerback, believe it or not. But and so it's just not worth it, right? Their future is entirely going to be determined by their ability to use their brain, and so why compromise that? But yeah, so long as people engaging in the sports are aware of the risk that they're taking, and I think for the most part these days people are. at least at the professional level, then I think it's okay. And like there are other sports where you can get a concussion, right? I mean, water skiing, you can get a concussion. Wakeboarding, snowboarding, skiing, all of these sports or athletic endeavors can be associated with head trauma. So, so yeah, I just don't look at the world that way, where like the number one priority is to minimize any probability of getting a head injury. Rather, it's just people should be aware of the risk that they're taking. Well, some forms of activities are good for releasing aggression. What's interesting? It's interesting you say it that way. So I'm not criticizing the way you're phrasing it, but back in the day there used to be this theory of aggression, where it was sort of like humans had sort of like the way that aggression works in humans, and this is not the case. This is not true. But the way it works is that you can think of it as sort of like a bucket, and certain things, increase the level of fluid in the bucket of aggression, and certain things reduce it. But at a certain point, if you fill it up enough, it'll spill over and somebody will engage in outward aggression. That's just not how aggression actually works in the human brain. And so it is just not true that like you need to, find ways to express aggression, otherwise it'll bleb out in some other way. Rather, certain things can reinforce aggressive behavior and actually exacerbate it. So, we're getting a call in. Oh yeah, T-Bone Productions, I believe. So what's your name and where are you calling from? Are you there?
Tyler, tuning in from Fishtown again.
Oh, that's awesome. I was hoping you would call in. Hey, what's up, Tyler, in Fishtown, Philly? The second Philly caller, by the way. What's on your mind today?
2 in a row. Well, I was wondering if we could expand this talk into, maybe have some insight onto technology aiding us as far as protecting the brain, like is helmet technology where it should be? And then also, what other devices do you foresee us maybe using in the future to improve the function of our brains?
Yeah, it's an awesome topic. And I hope you'll remind me that I did look into some of the neurobiology of savant syndrome, which you brought up last week. But yeah, so on this topic, actually at Penn, the University of Pennsylvania, where I work, in the bioengineering lab or department, they are specifically working on improving a couple of things. First of all, improving helmet technology, integrating more force meters and accelerometers and stuff like that, so that objectively, remotely, the team or some kind of health official can be essentially notified when somebody has had, cross a certain threshold of acceleration, such that they likely had a concussion, and then you can mitigate the likelihood that they will have a concussion, or that or recognizing if they have, right? So there's that. Another is that, believe it or not, not all helmets are created the same, as perhaps is intuitively the case for most people. But believe it or not, high school football teams and even professional football have not been using the best rated helmets available, which I think in the case of high school teams, that's unforgivable. And I think it should just be mandated that the highest rated helmet needs to be used in any justified, high school football program. Okay, so beyond that, yes, integrating more technology into the helmets and improving the availability of higher quality helmets, there is also, on the sort of back end, on the medical end, developing mechanisms to measure the severity, or to distinguish the severity of concussions, because it's not entirely clear, it's not always clear when somebody's had one. And it might not be clear until far down the line when the repercussions present themselves. And so that involves using neuroimaging techniques, using artificial machine learning techniques on neuroimaging to recognize extraordinarily subtle signatures of a concussion when somebody comes in. So yeah, there's a lot of innovation going on multiple levels, yeah. So there's cause for optimism there.
That's pretty cool. Yeah, so that would make sense, because we do have the technology to detect those G forces and impacts, little stickers you can stick on that have a little cell that will burst under a certain pressure.
Yeah.
That should be built into all of our helmets. So be like, you got hit pretty hard, you should check yourself out.
Yeah, absolutely. But I mean, it's not like the NFL is an impoverished organization, right? I mean, they could put like the same accelerometers that we have in our iPhone, or I actually don't have an iPhone, but in our smartphones, right? You can know very precisely how rapidly you're moving. And, it's not like the NFL can't afford that. And the other thing is that, okay, so let's say, okay, you've registered that somebody's had a concussion. So what? Sometimes it's very obvious when somebody's had one. Well, here's the thing. It's not always obvious when somebody's had a concussion. And after you've had even a subtle one, a mild one, you are more likely to have a subsequent concussion soon thereafter, right? And so yeah, like absolutely integrating that technology is sort of like, maybe they already have and I'm just not aware of it. But as of like a few years ago, they hadn't. So yeah, I mean, it's an interesting topic, though.
Would you say that there's a probable cause then for them to avoid using that technology, to avoid the complications of the consequences of knowing how dangerous something is?
Like far be it from me to engage in conspiracy theorizing, but I mean, at a certain point, you have to ask, like, why are you not doing more about this? This is now pretty, it's negligent. It's like uncontroversial to argue that like the labor force of the NFL is at a substantially elevated risk of concussion, right? That's not the case for carpenters or for fast food workers, right? And so it's like, it is in the best interest of your labor force that you use this technology. And so, yeah, I mean, but again, it could be the case that, I think his name is Robert Goodell. Maybe they already have, integrated all this tech and they just don't want to make a big splash about it. And if so, good on them. But yeah, I mean, I couldn't tell you, but yeah, I mean, and it is, you don't have to be too conspiratorial to recognize that there are some benefits to not making this such a big deal. So yeah, but I couldn't tell you that.
I could actually kind of imagine it in a sick way that people would imagine or would enjoy seeing the G-force meter jump up on the replay.
That's a super interesting thought. I hadn't thought about that. That is really interesting.
6 Gs.
Yeah, I mean, and also in professional fighting, I could imagine like, man, his punch was, 70 pounds per square inch or whatever. Yeah, like that's true. That is an interesting. Maybe you should pitch that to Mr. Goodell. All right, man. Well, so last week you brought up savant syndrome, and so I looked into it. For anybody that's not familiar with savant syndrome, this is a very, very rare. I think it's like 1 in 4 million or something like that. It's exceedingly rare condition where somebody is able to do like almost superhuman cognitive exercises. Like they can perform calculations that would typically, require at least a calculator, if not a computer, just at the top of their, just using their mind. And so there isn't a very exhaustive evaluation of the neurobiology of savant syndrome, but there are some threads that we can pull a little bit. One of the theories that I've seen that came out about 10 years ago was that you can actually transiently induce a savant syndrome using transcranial magnetic stimulation in an area of the temporal lobe. So basically, if you inactivate this part of the temporal lobe, people can exhibit savant-like characteristics. And, we know that damage to, very selective damage, like from, like traumatic brain injury, can result in a savant-like capability. And so the theory is that it could be the case that for those of us who do not have savant syndrome, there is a relationship that cortical brain regions have with deeper subcortical, more evolutionarily ancient brain regions, in that the cortex oftentimes inhibits them. And so if you take the brakes off of some of that inhibitory signaling, it could be the case that people who have savant syndrome just have access to a sort of repertoire of brain activity that is inaccessible to somebody without that unique brain architecture or who hasn't had that kind of brain injury. That was a kind of a compelling articulation of what might be going on there that I hadn't seen before in the literature.
Yeah, sort of like accidentally short functioning program.
Yeah, exactly. And that it is, once again, it's exceedingly rare, and perhaps as a result, it is understudied. But yeah, I mean, for me, that could help to explain, like people who, for example, have even rather debilitating autism, but who can recapture like a gigantic, almost photographic image of like an urban area, capturing like just minute nuances. And like, how does somebody, obviously they're capable of doing it. They demonstrate they can do it. But they also have all of these other, neuroanatomical abnormalities. And so it was a compelling theory. But anyways, Tyler, as always, great to talk to you again. And I hope to talk to you next week.
Appreciate it.
All right, Tyler from Fishtown. By the way, if you've been to Philadelphia and you haven't visited Fishtown, you should check out Fishtown. It's pretty cool. Why do I sometimes lose my train of thought, or certain words can't come to me when talking? That's that is a déjà vu-like phenomenon. Well, you're not necessarily exclusively referring to this, but there is a déjà vu-like phenomenon called presque vu, tip of the tongue syndrome, where you know a word, but all that you can think about is the wrong word. For whatever reason, your brain has decided, no, it is not GABA that you're trying to say. It's gabapentin that you're trying to say, or gabagool. And it's not gabagool. I know it's not gabagool. It's, God, what is it? That's tip of the tongue syndrome. Presque vu. Yeah, I think it's presque vu. I might be using the wrong one, but anyways, who cares? It's tip of the tongue syndrome. And so we don't know precisely why this happens, but one of the most compelling theories that I've seen is that the way that words are selected as you're sort of moving your way through a sentence, like I don't know what the next word is going to be that I say. But so what's happening is that you have, and it's kind of similar to your motor system, where, believe it or not, let's say, I stick one finger up, or I stick one finger up. The way that happens is not that my primary motor cortex send a signal down to through my spinal cord out to my finger to contract all the muscles necessary to do that. That's not how it works. In fact, the way it works is you have two competing motor systems, one of which says, open all of the fingers. The other one says, open none of the fingers except for this one. Actually, the way it works is that, okay, you get the open all of the fingers signal, and then you get another signal that says, inhibit this finger, this finger, this finger, this finger. So you get that, right? It's like this messy system. But so you have this excitation and inhibition tug of war that then produces the intended motion. And that's kind of how language works as well, where you have this huge repertoire of words from which you can choose. And it's basically, the striatum is thought to be the primary neuroanatomical structure that is implicated in this. It inhibits all of the various other choices that you could be making in favor of gabagool. And because all those other words are inhibited, they're just not available to you. And so you keep saying gabagool instead of GABA until you move on. And your brain is no longer inhibiting all those other, the striatum is no longer inhibiting all those other choices, or it might be the anterior singular. And then you're like, oh my God, I was literally saying gabagool instead of GABA. That happened to me during GABA. Oh, you know what she's saying? She's saying pasta, because that's her favorite food. Pasta. That happened to me during my defense. I kept saying short nucleotide polymorphism when I should have been saying single nucleotide polymorphism. And believe it or not, like the day before, because when I first learned about single nucleotide polymorphisms, for whatever reason, I decided in my mind that it was short nucleotide polymorphism, which is almost a meaningless statement. And the day before, I was like, single nucleotide, single nucleotide, single nucleotide. And then I go to my defense, and guess what I say over and over again? Short nucleotide polymorphism. So, yeah. She's saying pasta. Okay, this guy played Hamilton, right? No, I did not. That was Lin-Manuel Miranda. I am Ian McLaughlin. But believe it or not, it's weird that you bring it up. The first time I ever listened to any of Hamilton was 2 days ago. And I think it's going to catch on. I think it's pretty good. The activist David, basta. Can ice cream headaches, cause of ice cream headaches due to MS? Okay, I suspect that is a component of, either a component of MS with which I'm unfamiliar. Of course, multiple sclerosis is what our friend Jans is referring to here. She's very enthusiastic about pasta. Let me tell you. She also, yeah, well, so there are various pain-associated experiences that can occur as a function of multiple sclerosis. But I'm not familiar with one just being referred to as ice cream headaches. I can tell you the biology of an ice cream headache, a brain freeze, but it would not share any features of the biology of multiple sclerosis. The reason we have a brain freeze is that, so, let's say you're eating ice cream or you're drinking a slushie or whatever, something really cold, and your mouth is one of the most vascularized parts of your body. There's just tons of blood vessels that inhabit your mouth, roof of your mouth, your tongue especially. And so what happens is that there's an extraordinarily rapid temperature exchange that occurs between that really, really cold stuff and your blood right there. And then, because in the cold, blood vessels constrict, as that's extraordinarily, some of that extraordinarily cold blood then makes it up into the brain. What you get is an extreme cold, an unusual cold exposure, and then those blood vessels respond in a way that's unnatural. And so that's why it occurs very rapidly, and then it abates really rapidly, because then that blood is rapidly, replaced with, body temperature blood. So, yeah. Pasta, it's a true Philly kid right there. Yeah. Actually, we get some of this pasta from a restaurant in Philly, nearby. I guess that's not surprising. What am I going to get it from a restaurant in Italy? Okay, let's see. She's saying, Pastor, why we can't grow a brain? I'm not quite sure what you mean by that. Why we can't grow a brain? I assume you mean like in a petri dish or something like that. So here's some strides that have been made towards actually growing a brain, right? There's a new technique in neuroscience called organoids, where basically, let's say you're trying to understand the neurobiology of schizophrenia, okay? Schizophrenia arises from a kind of a diverse constellation of biological changes, right? Genetic, it can be environmental exposure to a traumatic experience that precipitates the schizophrenia. But the point is, it's not just like one kind of neuron or one gene that is altered to produce schizophrenia. It is a combination of a bunch of different factors. And so if you're trying to understand schizophrenia and all you're doing is studying specific neurons or specific genes, you're not going to get the forest for the trees of schizophrenia, right? And as a result, if what you can do is actually grow a kind of network of neurons, a collection of neurons that self-organize in such a way that they kind of it's like a simulacrum of a brain, then you can start to study these neurons in their natural habitat. And they will exhibit more of the characteristics that are associated with schizophrenia. So it's not like, and by the way, you implant those organoids in the brain of an organism. And some really weird philosophical questions begin to present themselves, right? Because these are, you can implant a human-derived neuronal organoid into an animal. And so they have a little bit of a human brain in an animal. And, that's just one example. Like another example is, was it? I'm trying to remember that animal. Shoot. I can't remember if it's rodent or something else, but if we replaced the human form of a certain kind of master regulatory gene called FOXP2 into these animals, their ability to exhibit more language proficiency was dramatically increased. I can't remember what the animal was, though. That's so frustrating. Anyways, yeah, so what happens, right? If there is like a non-trivial number of human neurons interacting with the brain of another animal, like what does that alter their conscious experience? Or is it meaningless? Is it sort of like just having a small tumor? Yeah. Gotta go. Thanks for my pleasure as always, Tyler. Have a great rest of your Sunday. Why does hair grow from the brain? It doesn't. Hair grows from the scalp. Personality disorders like BPD, a brain malfunction. So I assume you're referring to borderline personality disorder. The only reason I say that is what BPD typically stands for, but some people refer to bipolar disorder with BPD. But both are, insofar as they have any relationship to the brain, they both do. And they both arise. She loves pasta. She knows what she likes. She's a woman who knows what she likes. So they both are psychiatric conditions that arise from a unique alteration of brain activity. Now, it can be that one has a genetic, an inherited predisposition to developing these conditions. It can also be, a unique set of experiences that were highly traumatic that can increase the propensity that somebody will develop borderline personality disorder or bipolar disorder. And it is, the reality is it's a combination of both of those things where, somebody might have just be a little bit more likely to develop a psychiatric condition, but then they are severely abused and then that puts them over the edge. Or it could be that, you're a little bit more predisposed to, borderline personality disorder, but you don't really ever have a very, very severely aversive experience in your childhood. And so you never really observe the consequences of those predispositions. So yeah, but yeah, I mean, if you're interested in like helping somebody improve the quality of their lives who has borderline personality disorder, you would be engaging the brain through different mechanisms, one of which being just medication, right? That can always help, but then also psychiatric or psychological counseling, psychotherapy, and so on. Those, and usually the combination of those two things can result in optimal outcomes. So yeah, oh man. Thank you so much for the super hearts, C. Anderson or Rebel Dog Duke. Appreciate it. Italian baby. No. As far as I know, I feel people always tell me that I look like their ancestry. Like people have told me that I look like Southeast Asian, Middle Eastern, particularly in Dubai. People thought I was Emirati, and Italian or like Mediterranean. But no, I'm just like a European mutt and a lot of Irish. Yeah, borderline personality disorder. Okay, good. Activities or exercises that maintain brain function as we age. Yeah, that's a great topic. So the short and disappointing response is that there is no like one cognitive task that uniformly, consistently, generalizably improves cognition in everybody who does it, right? So it's not like there's a magic set of, if you do Sudoku, you read a book, you do some math equations, and, you eat pasta. It's not like that combination is cognitively nutritious for everybody. However, there is plenty of evidence showing that I'm going to say, increased educational attainment, but it's not like it's specifically going to college or something like that. It is just we use increased educational attainment as a proxy for sustained cognitive challenge later on into life, right? It just means that, the assumption is that it's more likely that you're being cognitively, challenged with novel ideas, okay? That is associated with lowered, with reduced probability of dementia. There are some interesting differences there, though. Like, for example, increased educational attainment is also associated with if somebody's going to develop Alzheimer's disease, it is a more rapid decline, which is kind of interesting. But yeah, so it's just cognitive challenge, continuing to force your brain to solve novel problems that could be associated with benefits in longevity. There's also, non-cognitive things that you can do. As I said much earlier on, engaging in cardiovascular exercise about 3 times a week for 20 minutes. That has been shown to be beneficial. Avoiding simple carbohydrates, avoiding sugar, like our friend Chris in San Francisco, and I avoid soda. I think that's probably like one of the easiest things that you could make a change that you can make on your own, which is like soda is candy. But I think a lot of us treat it like it's sustenance, like a beverage, like water. But yeah, like, simple carbohydrates, sugar, there's really no good reason from the brain's perspective to eat that unless you're in very specific circumstances. There's like the mind diet or the Mediterranean diet is typically the one that's recommended for sustained cognitive health as we age. And then another one that is, perhaps would be unsurprising to a lot of folks is avoiding becoming socially isolated as you get older. I don't know if this is the case outside of the United States, but I certainly know within the United States, it is very
it's too common that as people get older, they become socially isolated. They no longer have like a job or, you know, whatever, like their kids no longer live with them if they had kids. There's just no like activity that like requires their social interaction with others. And so it just can become easy to like just sort of withdraw and not be exposed to new people or interact with new people. So social isolation is one of the risk factors for developing dementia. In fact, I think a former Surgeon General suggested that social isolation is like almost equivalent to like, well, you know, it's almost equivalent in terms of its potential threat as like you know, depression or psychiatric conditions. Okay. How about a violent elderly? I'm going to kill you, MFer. 3 hours. How can I talk to their doctor? Oh, wow. Jeez, I'm sorry to hear that. Yeah, I mean, so that can happen as people get older, particularly as they develop dementia. You know, it's kind of unpredictable. In some cases, dementia can be associated with like sort of being rather passive and even kind of euphoric, or just content. There's like this contentedness that can be associated with it. But unfortunately, that's not always the case. And sometimes it can be, you know, a deterioration in their ability to, or in our ability to recognize somebody as kin or ken, right? As a friend or as somebody who's not a threat. And as, you know, there is a sort of like global deterioration of the ability for different brain regions to communicate with one another, you know, humans are quite predisposed to threat detection, right? There's like a reason that we tend to focus our attention on negative aspects of our world, of our surroundings, of, you know, a negative, you know, criticism of you when, you know, far more people complimented you. It's the negative criticism that sticks out. We are so composed. And so as, you know, one's brain is beginning to deteriorate as they get quite a bit older, that can become a problem that presents itself. And so, you know, yeah, you can, I mean, I don't know why you would be unable to speak with their doctor, but that's certainly something to bring up, particularly if they're literally threatening you that way. My dad was Air Force intelligence. Wow. Well, yeah, I'm sorry to hear that. But yeah, I mean, it's absolutely something to bring up with their physician. Their physician won't be able to share like intimate details because of what's something called HIPAA laws. But you know, you can give them information. Hey, what's up, Usama? Good to see you, man. Or I guess I don't know if you're a man. I guess I'm just saying two ideas aren't conflicting. Oh, sorry. Okay. I am interrupting a broader conversation in my ignorance. Studies about talking with your hands benefits. Oh, who does more, natural versus learned? Frankie Knuckles. Yeah, I literally just did it now. I inherited, I think, a you know, severe propensity for gesticulating. My dad does it a lot too, like, and he has like his like big hands and like, you know, there's like a strike zone that you can get into if my dad is talking, particularly if he's like getting like you know, passionate about any given topic, like yeah. So here's something that's interesting. Okay, so you know, I have a 1-year-old. You're hearing her sort of exploring her lingual landscape very voraciously, but she was not born deaf. For children who are born deaf, who are exposed to maybe parents or you know, caretakers who are familiar with American Sign Language, they will babble in sign language using their hands. Not like that, but and so, you know, if you've ever had a kid, you know that particularly when they're quite a bit younger in the first few months of life, they will, before they're like babbling like you can hear my daughter doing right now, they will tend to babble themselves to sleep, and you'll hear just like you know, odd, like they're just sort of playing with their tongue and their lips and their voice, right? They're not necessarily trying to imitate a specific sound that they've heard. And in fact, there's actually no solid evidence that doing what I've done with my daughter, which is like try and get her to say mama or dada, there's actually no solid evidence that actually is associated with improved language acquisition, believe it or not. I still do it because I find that hard to believe. But but yeah, so babies will often babble themselves to sleep. But for children, again, who are born deaf and who are exposed to American Sign Language, they will babble in American Sign Language at around the same time. It's interesting because it's completely unrelated. That kind of thing is not related to, for example, Broca's area in the brain, which governs essentially your ability to move all the muscles in your mouth necessary to say the word Broca, not only Broca, any word. And actually, interestingly, Broca's area, I always neglect to mention this because it's in a kind of cool part of the brain. It's at basically like the bottom tip of the primary motor cortex, in an area of the motor cortex that is responsible for the mouth, unsurprisingly. But it's like where the lips are, where the tongue is. And the primary motor cortex is arranged topographically. So this part of the motor cortex governs the legs. This part governs, the ankle. This part governs the fingers. And it's not laid out like a human body lying down on your brain. It's like you can have weird parts that are adjacent to each other. But anyways, that's where Broca's area is. It's in like the parietal lobe, basically. So what is this thing that I do with my hands? It's so obnoxious. It's called prosody. So there are prosodic components of language. So those are things like intonation of your voice, facial expression, gesticulation, that are also part of communication, but are not verbal. All right. Why do antipsychotics cause facial twitching? Yeah, so that is a side effect or a syndrome called tardive dyskinesia. Tardive dyskinesia. Thank you, I got it right. And it is a sort of known classic side effect, particularly of antipsychotics that target the dopamine system, like haloperidol can be associated with that. And it's just because that neurophysiology doesn't only influence the symptoms of, psychosis or whatever is they're being used to treat, but they also govern movement. And so that's just an unfortunate side effect of how that neurophysiology is wired. So yeah, okay. How long has it been? Have I missed like a bunch of YouTube comments? I have. Oh gosh. Yeah, Presque-Vu is tip of the tongue syndrome. Awesome. In which that you know something but can't quite recall it. Awesome. Thank you, Charles. I appreciate that, man. Okay. All right. I should probably call it a night. So in case you're interested, I have a YouTube. You can find it by searching like Ian Mickle or Ian Anthropoid Brain or something like that. I talked about a study that came out of Italy showing some interesting changes occurring in a classic network within the brain called the default mode network in people who performed a certain kind of meditation for 3 months. And it's an interesting study. You should check it out. Thank you very much for the super hearts, you guys. Joy. And I don't think I recognize you. Janice, thank you so much for the super hearts. Oh, and yeah, okay, and Renee. Okay, so you can check that out if you'd like over there. It's a cool study. Oh, I also debunked one of those not memes, those sort of viral biology videos where the brain seems to move a lot more than it really does. You can check that out in the same video. I also have a podcast called Wired to be Weird. It's available where all fine podcasts are podcasted. And I have a Patreon. It's patreon.com/anthropoid. If you're in a position to contribute anything, I would deeply appreciate it. Other than that, thank you so much for joining, and I hope you have an awesome rest of your Sunday. And if I don't see you earlier this week, I'll see you same time, same place, right here next Sunday. See you guys. And see you guys. I'm just going to bring up that video one more time, because I think it's just so cool. Yeah. It's just such a cool video. All right. And with that, see you, everybody. Thanks for watching.